Hey everybody, welcome back. Today we're going to start talking about algorithms. First of all, we're going to talk about what they are and why you should learn about them. And then we're going to figure out how to create a pseudocode for insertion sort, one of the most common sorting algorithms in order to sort a list of things from, say, lowest value to highest value. And there are many other kinds of algorithms, but we'll start with insertion code. Stick around. Thanks for joining me, and let's get started. Let's talk first about the type of problem we're solving. And generally what we're trying to solve is this sorting problem. The sorting problem can generally be described using the inputs and outputs you see here. You might look at it as a way to take an input, a sequence of numbers, and here I've got them generalized as A1, A2, all the way to AN for some n number of inputs in some list. So for example, you see this number list here, 2, 17, 1, and so on, all the way to 3. And that could be a possible input to the sorting problem. An output that we're looking for is that same set of inputs, but in ascending order. And that's what this describes here in symbols. In the example given here, we're looking for that list to be sorted from 0 to 17 in this case. Now, with that generalized description of the sorting problem, I can describe what insertion sort does, or how it works in order to sort a list. So for example, consider this input we have here, we'll call it input A. Obviously it's not sorted. What we want is to instruct the computer to sort this. So now I can describe insertion sort and the way it works. Here's that same array of numbers, and I've highlighted the first two. And the way insertion sort is going to work, and you see this on the left here, index 0 and index 1 are highlighted. That's what 0 and 1 indicate. And above the first two elements of the array, I have I and j. And so the question is, on every iteration of this program that we're going to write, insertion sort, going through the array, you have to ask yourself, is the number to the left, the one in red in this case, greater than the number to the right, the one in green? And the way you would look at that programmatically is the value of the array at I, that's A of at I, as I show you here, greater than the value of the array at j, that's A at j, if the array is given the variable A, for example. So we do the comparison and we realize, yes, 10 is greater than 8, so we have to swap the 10 and the 8. And that's what you see here. And then once that's done, you have 8, 10, 7, 0, 1. And so the first two elements are sorted in a sense. And then you go and increment I and j, and you look at the first and second elements, and that's what we're seeing in this last row here, and you're comparing 10 and 7. And again, you're looking at whether or not the item to the left is greater than the item to the right. It is, so you swap the 10 and the 7, and then you still have an 8 to the left of the 7 once you do that, so you swap those, and then you get 7, 8, 10, 0, 1. And you continue in this way, keep incrementing I and j, and every time you increment I and j, you do the comparison of the jth item to the ith item. So in other words, the item to the right is compared to the item to the left. If the one on the left is greater, you swap. So in this case, we have 10 and 0, they swap, then you swap 8 and 0, then you swap 7 and 0. And you end up with 0, 7, 8, 10, 1. And finally, you get to I and j at the third and fourth position, and you start swapping till the 1 eventually makes it to the beginning. And then once it gets to 0, it won't swap because 0 is less than 1. And so now we have the sorted array, 0, 1, 7, 8, 10. Great, now that we've figured out how to solve this problem using a given sorting procedure, in this case insertion sort, we can come up with an algorithm in pseudocode to do just that. So a couple things to note right off the bat. I and j are indexes that are 1 apart. I starts at 0 and j starts at 1. J ends at the end of the array, which is the length of the array minus 1. Remember, the index goes from 0 to 4, and the length of the array is 5. I will be whatever j is minus 1 in all cases, because it just sort of follows it along. And we're going to use that to our advantage to write the program or the algorithm. And the other thing to note is that when you make a swap, you're not done after one swap. You keep swapping until the number to the left is less than the number to the right. Until that happens, you just keep swapping. Okay, so let's start writing this algorithm. I'm going to call it Insertion Sort, and so I'm just going to type that in as the algorithm name. And I'm going to use parentheses to indicate this takes some input, A, which is going to be an array or a list of numbers. And remember, we want to iterate through the array, and so I'm going to say for j, remember j goes from 1 to the length of the array minus 1. What I want to be able to do, use whatever value I'm currently at and put it in a temporary variable. So do take a key variable, let's call it key, whatever the value of the array is at that jth element, put it in the key, because that's the one currently being considered, being compared to the values to the left. I'm going to take I, remember I is whatever j is, minus 1, so I'm going to take I and make it j minus 1. And I'm using arrows, you can use equal signs if you want. And then we want to keep swapping. So while, and there's a couple conditions here. So while I is greater than or equal to 0, and the value of I is greater, the value of the array at I is greater than key. In other words, the item to the left is greater than whatever you put in the key. You want to do a swap. And to do a swap, what you'll do is do AI plus 1 and set it equal to whatever AI is. In other words, take that item on the left and put it on the right. And then you're going to decrease I by 1. And that while loop will keep going until one of those conditions is not met. Either I is not greater than or equal to 0, or the item to the left is less than the key. This will conclude the inner loop, and then the outer loop, you just have to take the key and put it down, because you finally found the spot where the key belongs, and you put it into the spot where it belongs by saying AI plus 1. Now you can use whatever IDE you want on Windows or Mac or whatever system you're using to program in C. I would recommend CLion. That is not free forever, so you can get a trial for if you're just doing tutorials for 30 days, but it would cost you money. Another good IDE to use on a Mac for using or for creating C, C++ files is Visual Studio Code. You just have to download the right packages for Visual Studio Code so you can program in C. On Windows, you have more options. You have Visual Studio. You have several other programs. There, I would recommend Visual Studio because that's a great Windows product for programming in C. Incidentally, you can get Visual Studio for Mac, but it doesn't have support for programming in C. It does for C# and some other languages. I'm going to go ahead and use CLion in my example, but feel free to use what you'd like. Okay, so here we are in CLion, and I'm going to create the program first by writing the pseudocode, copying the pseudocode down here, and now we're going to implement that algorithm in C. Now to start any C program, you have to import, or in other words, include libraries. Use the #include keyword, and you'll see this very common in C. You'll include the standard IO header file. That's what this is. Don't worry about it too much, just realize that if you're going to input or output to the console, you're going to need that. The next thing I want to do is just jump right in and start implementing this insertion sort pseudocode that we have above. I'm going to say void insertion sort. Insertion sort is the name of this function. And it's going to take a couple of arguments. I'm going to take an integer array, and we'll call it ARR. And then I'm going to take the size of the array. You might think, well, if you already have the array, you can get its size, so why take both parameters? And I'll show you why, in this case, why I'm going to do that. It doesn't make much difference if you do or not, but in this case, but it has to do with how many times you have to calculate a value. So I'm going to need a couple variables here. I'm going to need some variable to keep track of the outer loop. So I'm going to say I and key. And I need those because of the way the algorithm is written, as we described earlier. And then I'm going to have a for loop as the j value, the green box in our examples that we showed, as that marches forward from j equals 1 to j less than n, which is the size of the array. And inside, every time it iterates, we want the key to be whatever the value of the array is at j, because that's the one being considered and compared to the items to the left. Then I take I and set it equal to whatever j is, minus 1. Then while, and this is where you keep comparing to the items to the left, while I is greater than or equal to 0, and the array value at the ith element of the ith index is greater than key. In other words, while the thing on the left is still greater than the thing you're comparing to, make a swap. Take that ith element and put it to the right. So array I is being stored in array I plus 1. Then you decrement I. And you keep doing this, and you're shifting everything to the right so long as the thing on the left is greater than the key. The last iteration of this while loop will place I at the position to the left of where it really needs to be. So you need to go back one more, or go forward one more, I plus 1, and set the key down there. And this should complete the sort that we described above in the pseudocode. So now you see another, a great example of why the pseudocode is so useful. Because if without having written it first, we would be struggling here to write the code, because it's hard to conceptualize what you're trying to do with the i's and the j's. But once we saw how insertion sort is supposed to work, and then we were able to write the pseudocode, it was much easier to write the actual code. Okay, so we now need a program to actually run this, and maybe even a way to print the result so we can verify that the input is in fact sorted into an output in ascending order. So first let's write the main function, and that's what it's called in C. And here you can write void or leave it blank. There's some esoteric reasons why you can add the void there or leave it blank. So int array, and we're going to create one right now to use as a test. And I'm going to say 12, 13. The output will be 5, 6, 11, 12, 13. What I want to do now is get the size of the array. And in C, there's no array size function. So what you do is you get the size of the entire array in bytes, and then you divide it by the size of the first element of the array. Because they're all the same size, when you divide, you'll get the length of the array in integers. Now I can just call insertion sort on array and n, and then I'm going to create a function to print the array, and we're going to pass array and n again. And this is why I calculated the size of the array here and passed it, because if we didn't, we'd have to get the size and calculate it in insertion sort and in the print function. But if you just calculate it once here and then pass it as a parameter, it's one less calculation you have to run. I'm going to say print array, and it's going to take, again, an int array input and a value for the size of that array. We're going to iterate through, and all you want it to do is printf. So that should do it. And now when I run this program, it should sort the input array that we have there. So we have 5, 6, 11, 12, 13. It worked. Perfect. What happens if we add more numbers? What if we have duplicate numbers? What if I had 5, 6, a couple duplicates, then I add 19, 11. It's still sorted. 5, 5, 6, 6, 11, 12, all the way out to 100. So this program appears to be working perfectly. As I said at the beginning, we're going to implement it in Python as well to show you how you would do this using the same algorithm, but in Python. So now I've started another project in PyCharm to do a Python version of this insertion sort program. And I've pasted the exact same pseudocode here that we used before, that we developed on the Sketchpad. And we're going to implement it now in a completely different language from C. And here we go with Python. So I'm going to remember to define a function in Python, use the def keyword, use def, and I'm going to call this insertion sort. And it's going to take array as input. Oh, you don't need curly braces, you need a colon. And then for j in range 1 to length of array, what I want to do is take the key and set it equal to the array value at j, you set I equal to j minus 1. And then again, we're going to do a while loop. I is greater than or equal to 0, and array's ith value is greater than key. While that's the case, you're going to keep shifting to the right. So array's I plus 1 value will be the array's ith value. And then every time you do that, you're going to decrement by 1. So you can say I minus equals 1, or I equals I minus 1. Same thing. Once you're done shifting, because the while condition is no longer true, that means there's nothing on the left that's greater, then what you do is array I plus 1 and set it equal to the key you were comparing as you went along the whole way. And so this is the implementation of the same algorithm now in Python instead of C. And we need to test this, and as before, I'm going to use a test array, and let's give it a ARR, set it equal to, and the way you do an array is square brackets in Python. So that gives us something to test, and then I'm going to call insertion sort, or the array itself. And then I want to print it, and I'll just print it right here. First I'll create a blank space so it's easier to see. In fact, I'll create 2 blank spaces. And then in the middle here, I'm going to print the array using a loop. And what we want to do here is just print the array's value, and that should show us the final array. Next, we want to call main, and then a space afterwards. Okay, so now we have a way to call the main method. In the main method, we've provided a sample array to test, and then in that main method, we're also calling the insertion sort algorithm. So let's see if this works. And there we have it, 0, 1, 2, 3, 4, 7, 9, 9, 11. This is the power of algorithm. If we had to create this program from scratch after a demonstration of how insertion sort works without writing the pseudocode, we'd be struggling. But because I was able to translate what we were trying to do into a pseudocode first, we were able to translate that pseudocode further into 2 different languages in a very short amount of time, just by copying what we'd written into the new syntax. With this algorithm, if you really wanted to, you could go and do this in Swift, or JavaScript, or VBA, or any other language you want, because you just have to Google how the syntax works in that new language. For example, I've never used Go as a programming language, but if I wanted to, I could Google while loop in Go, or for loop in Go, and then that would show me how to do those items, and I would just translate the pseudocode into that new language. So well done. Congratulations on finishing this project, and let's conclude and figure out where we're going to go next. Okay, to recap, we did the insertion sort algorithm in this video. Here on the screen is the final product of the algorithm, and we were able to implement it in 2 programming languages, C, which we hadn't used before in this video series, and then Python, which we used once before. And what we noticed is that once you have the algorithm, once you've developed it in pseudocode, it's much easier to write the code in any language you choose. Algorithms are a way of solving problems programmatically, and efficient algorithms are important, So what I wanted to show you here, and is not that important right now, is that insertion sort has a time complexity of what we would call order n squared, and that's what this O n squared looks like in the worst case. In the worst case is when the input array is in descending order. That means that every time you do a comparison, a swap needs to be made until the whole thing is sorted in ascending order. Order n squared means this is basically a nested loop. You had an outer for loop with an inner while loop. So you traverse the array n times on the outer loop, and then you traverse the array n times on the inner loop. So for every one of the outer loop iterations, you're iterating the inner loop n times, and that means n times n or n squared. That's sort of a way of gauging the time complexity or how long an algorithm will take to complete. And it's not important to know right now because we're not going to do a deep dive into the mathematical descriptions of algorithms, but one way to consider algorithms is their order of time complexity. And in the best case, insertion sort would be order n, and in that case, the input array is already sorted. So you just traverse it one time, and every time you don't do any swaps. because it's already in the proper order. Space complexity is order n. That means the amount of space the algorithm takes is just the size of the input array, as far as the memory space that it takes. It also has an auxiliary space complexity of 1, or constant complexity, meaning you don't have to do much by way of memory outside of the array. You introduce a key variable, and that variable has a constant size, and it holds basically the value you're considering as you go through the array and determine where that key needs to go. So it needs to have the amount of space necessary for one integer variable outside of the array. There are other algorithms that are less efficient. Some may be more efficient at sorting. How efficient an algorithm is might be based on the types of things you're sorting. In the next video, what we're going to look at is a challenge. I'm going to introduce the bubble sort algorithm, another sorting algorithm. Your task will be to design an algorithm based on that description, and then to implement that algorithm in C++ and then in C#. So thanks for watching, and I'll see you next time.